Okay, yeah, we're live, so we'll start now.
Alrighty.
Okay, we'll go to part 1 of the lesson 12, inference for two means. So question 1 is, what does it mean to have matched paired data?
That it's like obtaining data from like the same individuals or like same sample, but from like two different tests of the same sample size, like same sample group.
Yeah, they have like a pre-sample and like a post-sample statistic of, yeah.
I like where that each row is connected.
Okay, let's go to question 2. What are the differences in the hypothesis test between a one sample unknown and a matched pairs open-ended?
Like one observation versus two observations.
Yeah, two observations of the same group rather than just one observation of one group.
Yep.
Okay, let's go to, I guess, part 2 then. So then the matched pair T procedure, a manager at a factory feels that the amount of time that his workers spend doing their part in the assembly line is too long. He measures the amount of time in minutes 9 of his workers take to complete 100 products. After implementing the new procedure, he again measures the amount of time in minutes the same 9 workers take to complete 100 products and obtains the following data. He wants to know if the mean assembly time is different and used the level of significance of the alpha equals 0.05. Use data link on I1 factory assembly times. So question, oh, go ahead. Oh. Part 3A is, what is the research question? What do you guys get?
Essentially, what is the mean wait time difference of the new loading procedure to what it was before? Oh,
Yeah,
is it different? I guess we should say, like, is the mean different from the old one to the new one?
I mean,
yeah, it should
obviously,
be. Yeah, is it different?
but the hypothesis is different. But they're really looking for less time, right?
Well, no, it's just different.
Yeah.
When I think when it comes to like these matched pairs, you're just looking if it's different, so it'll always be like not equal to. So the hypothesis is that the difference equals to 0, and then the actual is that it doesn't equal to 0.
That totally makes sense. But in my opinion, is back when I was an operational manager, why implement a new procedure unless it's going to save you time? But I understand that they're looking for something different.
Yeah, because I think they're just trying to see the data of like, was this a better choice or was this a worse choice? Because you don't want to like focus on one end, and if it's actually doing worse, but you only showed if it was doing better, like you just don't know, and so it's just better just to do not equal.
Right.
So that's the part B of question 3, isn't it? Is about how you write the
null and the alternative hypothesis. So it's, yeah, the null is equal to 0 and the alternative is not equal to 0.
So if the mean difference is not, yeah, okay.
Okay, question 4, collect the data, and it says describe the data collection procedures. I mean, they just took a sample from 9 factory workers before the change, and then they collected data after they made the change for the same 9 workers.
Right. Yep.
Yeah.
So And then question 5, describe the data. In a short paragraph, use summary statistics to describe the data. After the paragraph, insert an appropriate and well-labeled graph to illustrate the data. So what'd you guys do for their
I just plugged it in that
data?
spreadsheet. Got the D, the N, the standard deviation, the difference. And
I do have one question. For the SD, it says it's 2.596, but when I had
Right.
the 2 standard deviations, for the first set I got was 23.04, and then for the second one I got 21.79. So when I did the, I mean, is it just 23 minus 21? Because
So wait, did you try to do the standard deviation of the first group and then standard deviation of like like after the assembly line, or did you just do the standard deviation of the difference? If that makes sense. Like, did you use all only the difference numbers to calculate the standard deviation, or did you try to use the first numbers and the post numbers and minus the standard deviation?
yeah, that's what I did.
Yeah, so they're recommended not to do that. They want you just to, when you first get the data, you immediately create the differences. So once you have the difference data, that's the numbers you go off of, is the difference numbers, and then you just simulate, like do the same formulas as if it was a one sample. So if that makes sense, like
so how did you get the 2.56 then?
The 2.596
Yeah.
is, I just put in that little graph that they give us, the quantitative inference procedures. And what you do is once you calculate the difference, you plug in only the difference numbers in the variable column, and then it'll pop up the mean, the standard deviation, and like all those numbers.
Well, if you click on that tab at the bottom of the paired sample test, it'll put in the variable 1, 2, and the difference, so it comes up for you pretty easy.
Okay.
The tab at the bottom shows paired sample t-test. That's what I did.
Okay, that makes sense now.
Oh yeah, doing that one. Yeah, I didn't even know they had a page for that. So yeah, that might be easy too.
Well, it's kind of like Jack said the other day. We're teaching you the long way to do it, but you got these tools that'll help you. So
yeah,
it's easier. But it certainly is good to know it.
All right, perfect. And then
then I went to the other spreadsheet and did some histograms and checked those out.
Yeah.
should we move on to question 6, or is there like more stuff that we need to talk about in the question 5 part?
Well, the only thing I would add is it showed that the data didn't really show a significant improvements, but probably hard to tell with just a sample size of 9.
9, yeah.
Yeah, that's true.
Okay, so question 6, it says which part of the step make inferences. So what type of hypothesis test is appropriate? So since we have the, the paired sample test, we're going to use the two-tailed paired sample t-test.
Correct.
Yeah, because it's that, so it's not equal to, it's got to be two-tailed paired sample t-test. Yeah.
Then B, what what are the requirements for this test? What'd you guys get?
So it needs to be a simple random sample, and the sample mean of the differences has to come from a normal distribution.
Yep.
Because the samples had to run a QQ plot, see if it looks normal, which I personally didn't think it did, but it seems like some of the guys did, so it's close.
Yeah.
Once you sort it, for sure. If you don't sort it, it looks really bad.
Okay, let's move on to C. Compute the differences between the two times and determine if the requirements are met for this test. Explain your answer. So, I mean, because the n is not greater than 30, you know, it's the differences might not be distributed normally. But, I mean,
Pretty much, don't they say is like, yeah, it's hard to tell, but you should just go with the assumption. Like I looked at the answer cadence, it's like, oh, we'll just continue with our assumption of normality, but in reality, there's not enough things to conclude. Like, yeah, it's normal.
Yeah.
so with the information we got on, what is it, 5, we can get the test. What is it? The question. Continue with the test regardless of what you found. Compute the test statistic.
1.22.
Yep.
And then E, see the degrees of freedom. So 9 minus 1. Get 8.
8.
Okay, and then compute the p-value to the alpha level. Get the t-distribution using the t-distribution Apway. Did you guys get for the p-value?
That was 0.2572.
Yep.
Off that chart.
Yep.
Greater than the alpha.
So then that means, yeah, we're going to fail to reject the null hypothesis. Then G, rather than testing a hypothesis, now say you just want to estimate the mean difference between wait times at the 95% level. Be sure to calculate the margin of error. Go ahead and paste your results below. So I didn't get quite. Can you guys tell me what equation you guys used for this one?
Yeah,
To get the right numbers. Yeah, I know the 95 is 1.96, but what do I times that by? And
I didn't do it longhand. I just looked at the Excel spreadsheet. But
Yeah, so I'm gonna have to like go back. How you? Standard deviation.
so you guys just did it on the spreadsheet, you said?
Yeah.
Yeah.
but it would be the, gosh, what would that be? The
I'm just curious. So
standard deviation, the mean of that divided by the square root of the sample, right? And then the t course is 1.96, but that would probably work out. I've tried that. I can't remember. I didn't save that, so I did it. Yeah. Yeah, the sample standard deviation divided by the square root of 9 times the 1.96 should give us that number. Right? Plus or minus?
Yeah, plus or minus that from the mean, right?
Mhm. Can't remember the standard deviation of the difference though. Is that the 2.596?
Yeah.
0.596. Yeah.
No, yeah, that's it then.
Cool. Is that it? Oh, that doesn't look like you did something wrong.
Okay. Well, I'm good if you guys are good.
That sounds good to me.
I'm good.
Okay, then 7 question. In a short paragraph, describe the action those should be taken based on the statistical results above.
They just need to reevaluate what's taking the most time out of their assembly and really tackle that part because right now their new procedure's not doing anything. That's what I
some
come.
got worse. Overall, it didn't look like a thing they want to implement. Have to go back to the drawing board.
Okay, well, should we take the quiz then?
Yep.
Yeah.
Okay.